Good morning, students. So today we are going to look at some questions that had come up in TCS NQT, that is National Qualifier Test, as organized by TCS every year. And this year also it was organized for the upcoming batch of 2021. Now, talking about the sections that are there, so we have sections for quantitative analysis, logical reasoning, and verbal ability, along with programming MCQ and a pseudocode. Okay. Overall analysis of the difficulty level of the paper, if we do, so the questions were from a range of easy to moderate level difficulty. Most of the questions were not very difficult to solve. We can easily solve them if we know the logic, just application of logic in every question, that was important. Another thing about this paper is little practice is required with respect to questions that come up from time and work and permutations and combinations. Those two topics are heavily asked in TCS NQT paper. So we're going to look at some questions, how they were asked, how to solve those questions. And this is from set B because the paper was organized over a span of 3 days. So it had come up in sets. So we're going to look at set B of the paper. Let's see what the questions were. Okay, first question. 100 students appeared for two different examinations. 60 passed the first, 50 passed the second, and 30 passed both the exams. Find the probability that a student selected at random failed in both the exam. Okay, now this type of question can be solved easily using a Venn diagram, because when you have two or three quantities, it is easier to visualize them using Venn diagrams. So I'm taking my first test here, the second test here. Universal set, that is total number of students, becomes 100. Okay, now 60 passed the first. Here it's 60. 50 passed the second. Here it is 50. Now it is given that 30 passed both the exams. So this intersection portion, it's given as 30. All right. Next thing that I can find out is two students who purely passed first test. That is students who passed first test only. It becomes 60. That is students who passed first test minus those who passed both, comes out to be 30. Now, students who passed only the second test. So that is total number of students who passed the second test, 50, minus those who passed both of them, 30, comes out to be 20. Okay. This is given to me. And after this, what I have found out is those who passed just the first test only, those who passed both the test, and those who passed second test only. Now, after this, but they're asking me probability that a student selected at random failed in both the exams. So first I need to have those students who failed the examination. I will find that out by doing total number of students 100 minus those who passed in first only, minus those who passed in both, minus those who passed in second only. When I do this, I get value as 20. And this is going to be the students who failed in both the exam. After this, failed in both the exam, I have the number, I have the total number, I can find out probability. Probability becomes 20 by 100. That is 1 by 5. My answer is option C. Next question. A alone can finish the work in 10 hours, B alone can finish the work in 12 hours, and C alone can finish the work in 15 hours. A, B, and C work together starting at 11 a.m. After 2 hours, A leaves. When will B and C will together finish the work? Okay, easy question. I know. Total work that has to be done, it is equals to either 1 or 100%. But there is one more way of writing work, and it is called as taking the LCM of that time in which some complete work is being done. So if it is with respect to hours, take hours. If it is with respect to days, take days. If it is with respect to weeks or months, take that. So the time in which some work is being completed by some people, if you take the LCM of that, I'll get one value. Here, if I take the LCM of 10, 12, and 15, it comes out to be 60. And it is not just 60, it is 60 units of work that these people have to now complete. After this, what I do is I find the efficiency of three people. I find out their efficiency, the person's 1 day work. So if A has to do 60 units and is doing 10 units per day, so A's efficiency becomes 10 by 6. That is 6 units. Here it will be per hour. Now, B's efficiency, if we talk about 60 units they have to do, they're doing 12 hours per day, comes out to be 5 unit per hour. C's efficiency, if we talk about, C is doing 60 units. He's completing the same work. See, all of them are doing the same work. Becomes 60 by 15. That is 4 units per hour. All this is okay. After that, it is given after 2 hours A leaves. That means for first 2 hours, all of them were working together. So A, B, and C, they were working together. Time that they have taken is, or how much work they have done is A plus B plus C into 2. That is 6 plus 4 plus 5, 15 into 2. In 2 hours, they have done 30 units of work. Remaining work becomes 60 minus 30, that is 30 units. Now, since A has left, the only person who's remaining now to work, it's B and C. B and C, if they're together working, they're doing 9 units. If they're working together, they're doing 9 units. Now, if they're doing 9 units and they have to complete 30 units, how much time they would have taken? So, if they have to do 30 units and they are doing 9 units together, time taken by them would be 30 divided by 9 comes out to be 3.33 hours. Now, 3 hours I can find out after 2 hours A leaves. So A is actually leaving at 1 p.m. A leaves at 1 p.m. After that, 3.33 hours later, the work is completed. So 3 hours I can visualize. 3 hours is actually 4 p.m. But what about this 0.33 hours? This 0.33 hours I convert into minute and I'll add that up to 4 p.m. So 0.3 hour 0.33 hour is actually one third of an hour, and one third of an hour is 1 by 3 into 60, that is 20 minutes. So I need to add 20 more minutes to this. When I add 20 more minutes to this becomes 4:20 p.m. Time when they will finish the work now is 4:20 p.m. My answer is option C. Next question. A five-digit number is formed using digits 1, 2, 3, 7, and 9 without repeating any of them. Question is already stating no repetition allowed. What is the sum of all such possible numbers? Sum of all such possible numbers they're asking. They're not asking me how many numbers will be formed. Okay. Now, to find sum of such possible numbers and when no repetition is allowed, we have a formula and we're going to do this with formula only. When no repetition is allowed and let's say n digits are given to me using n digits, how many whatever the numbers are formed, what is going to be the sum? So if n digits is given, first I'll do n minus 1 factorial. To that, I'll multiply the sum of digits. And to that I'm going to multiply 1 1 1 1 until n digits I'm going to take. Okay, this is the formula. When I have to find sum of all such numbers without repetition, I'll do n minus 1 factorial. N is my number of digits. N minus 1 factorial into sum of the digits, sum of whatever digits is given to you into 1111 up to n values. Okay, n minus 1 factorial. N number of digits given to me here is 5. So here value of n is 5. N minus 1 factorial, 4 factorial into sum of digits. Sum of digit is 1, 2, 3, 7, 9. On adding that, 9 plus 1, 10, 7 plus 3, 10, 10 plus 10, 20, 20 plus 2 is 22. Into 1, 1, 1, 1 until n digits means I'll be having 5 ones here. Okay, now after doing this, 4 factorial is 24. 24 into 22 into 1, 1, 1, 1, 5 times. When we do this, it comes out to be 5, 8, 66608. When we do this multiplication, it comes out to be 58660608. My answer is option D. Okay, next question. A and B live in the same house. At 10 a.m., they together start traveling towards a T junction from their house on MG Road with the speeds of 20 km per hour and 40 km per hour, respectively. Okay. At T junction on their path, A turns left at 12 p.m., B reaches the T junction earlier and turns right. Both of them continue traveling till 2 p.m. What is the distance between A and B at 2 p.m.? And we have to find the distance from the T junction. Okay, now A starts at 10 a.m. with a speed of 20 kilometers per hour given to us already. So let's form a T junction. It reaches the T junction at 12 noon. Thus the distance at T junction from their house. Okay, so it has already traveled from 10 to 12. So for A, speed is 20 and it has already traveled for 2 hours. So distance becomes 20 into 2, that is 40 kilometers. Distance becomes 40 kilometers. Okay, now B will reach the T junction at 11 a.m. and turn right. So they are traveling at the same time. This 40 kilometer, if B has to travel, because it is already given in the question, B reaches the T junction earlier and turns right. So B would have already reached there at 11 a.m. because distance of their house from the T junction is equal to the distance traveled by A in 2 hours, because it is clearly given in the question that A reaches the T junction after traveling for 2 hours. That is, A reaches the T junction at 12 p.m. So whatever distance A has traveled in 2 hours, that is the distance from their house to the T junction. And it is given in the question, the next statement, B reaches the T junction earlier. So B also has to travel 40 kilometers only. B's speed is 40 kilometers per hour. So he has now reached there at 11 a.m. That is given. And now B turns right. It will keep moving at the speed of 40 kilometers per hour and he will keep on moving for 3 hours because it is talking about now 2 p.m. because has already reached at 11 a.m. Turns right, starts moving for until 2 p.m. That is, he is going to move for 3 hours. His speed is 40 kilometers per hour. Distance that he would have traveled becomes 40 into 3, that is 120 kilometers. He would have already traveled 120 kilometers. Okay, now distance between A and B at 2 p.m. Distance between A and B at 2 p.m. is what we have to find out. Okay, distance between A and B at 2 p.m. becomes 120 plus 40, that is 160 kilometers. Distance between them is directly 160 kilometers. My answer is option A. Okay, next question. A man sold 12 candies for $10 and had a loss of B%. Again, he sold 12 candies at $12 and had a profit of B%. What is this B that he is having? What is this B value? Okay, now in profit, first let's talk about. So in profit, selling price will be equal to 100 plus B divided by 100 into cost price. This is just using the formula of selling price and cost price and profit. Okay. Now, cost price will be equal to 10 into 100 plus B divided by 100. When 12 candies, they are sold at $10 and he had a loss of B dollar. This is the cost price that he would have had. Okay. Now, next thing. In loss, if we talk about if we talk about selling price right now will be equal to 100 minus B divided by 100 into his cost price. This is my second equation. Now cost price here will be equal to 12 into 100 minus B divided by 100. This is the general formula for selling price and cost price, but if we consider the loss and the profit, this is what it comes out to be: 12 into 100 minus B divided by 100. When my 12 candies, they are sold for $12 and the person have had some profit. Okay, now from the equation, these two are same. These two are same because every time he's having a B% profit and B% loss, every time he's having the same. All right. So in this case, what next step we are going to do is, I'm going to do 10 into 100 plus B divided by 100 is will be equal to 12 into 100 minus B divided by 100. When we do this, value of B comes out to be 100 by 11, that is 9.09%. That is, whatever loss or whatever profit he was having 9.09% profit, 9.09% loss. Okay, next question. A travels at 40 kilometers per hour, B travels at some other speed that is 60 kilometers per hour. They're traveling towards each other and start at the same time. Okay, traveling towards each other. This is A, this is B. Next thing, by the time they meet, B would have traveled 120 kilometers more than A. Find the total distance between them. Okay, now, first thing that I'm going to do is A's speed is 40, B's speed is 60. This speed is given to us already traveling towards each other also. Now, relative speed of A and B. When two objects travel towards each other, relative speeds is addition of individual speeds. So this becomes 100 kilometers per hour. Okay, now let the time taken by them to meet, let the time taken to meet, let it be t. So after t time they're going to meet. So the total distance between them, I know distance is equals to speed into time because speed equals to distance upon time. Distance is equals to speed into time. So distance between them is going to be equal to relative speed into time, 100 into t. According to the question, it is given that by the time they are going to meet, B has already traveled 120 kilometers more than A. So distance traveled by B is going to be distance traveled by B is going to be distance traveled by A plus 120 kilometers. This is what we are going to do. So distance traveled by B, B's speed, it's 60. 60 into T is equals to distance traveled by A. Distance traveled by A is 40 into T plus 120. When we solve this, value of T comes out to be 6 hours. Okay, I have the value of T as 6 hours. Distance between them is 100 T. That is, it becomes 100 into 6, 600 kilometers. Value or of distance comes out to be 600 kilometers. My answer is option A. Next question. The addition of 641 plus 852 plus 973, it is giving 2456. But this addition is not correct. What is the largest digit that can be changed to make the addition correct? Okay, so we'll have to change one of these 9 digits so that my addition becomes correct. Let's check for each place first. So 1 plus 2 plus 3 is 6. Okay, so this row is correct. Now, 4 plus 5 plus 7, 4 plus 5 is 9, 9 plus 7 is 60. So this was supposed to be 16, but it is 15. Carry over 1 we can do. 9 plus 1 is 10. 10 plus 14 is 24. So this row is also correct. All right. So the only though row that is wrong is my tens place. 4, 5, 7 giving me 9 and a carryover. Sorry, giving me 5 and a carryover. So what number should I change here? So the largest digit that I can change so that I get the addition correct. Out of these three, the largest number that could be changed is 7 because 4 and 5, if I change, I have a bigger number still. Okay, so the largest number that I can change here so that my addition becomes correct is 7. My answer to this is 7, option D. Next. Vicky can finish the work in 10 days. Bala can finish the work in 12 and Venkat can finish the work in 15 days. Again, it is always talking about the same work that three of them are doing. They all start to work together. Vicky leaves the work after 2 days and Bala leaves 3 days before the work was completed. Okay, 3 days before the work was to be completed, another person left. How long did it take for the work to be completed? Okay, again, total work here that they have done, I'm going to write it as LCM of 10, 12, and 15 because already explained work can either be 1 or 100% or LCM of those days in which some work is completed comes out to be 60 units. Vicky's efficiency becomes 60 by 10, 6 units per day. Bala's efficiency becomes 60 by 12, that is 5 units per day. Venkat's efficiency becomes 60 by 15, that is 4 units per day. Until here, this is no difficulty. We have not yet started the question. The next part that we have to look for here is the next thing that we have to look for here is it is given in the question that they all start to work together. So they are working together. V plus B plus VE. They are working together. And after 2 days, Vicky leaves. So after 2 days, Vicky leaves. That means they were initially working together. So if they're working together in one day, they'll be doing 6 plus 4 plus 5, that is 15 units per day. In 2 days, they would have done 30 units. So 30 units of work is done. Now Vicky is leaving. Remaining work becomes 60 minus 30, that is 30 units. This is after 2 days. Now Vicky has already left. 3 days before the work has to be completed, Bala also leaves. I do not know the time duration for which Bala and Venkat are working together. But I know one thing for sure, that for the last 3 days, only Venkat is working. I know for sure that for the last 3 days only Venkat is working because Bala leaves. So if Venkat does 4 units of work in one day, he's working for last 3 days alone. So work that Venkat has done becomes 3 into 4, that is 12 units. Alright. So now remaining work becomes 12 units is also completed. The remaining work becomes 30 minus 12, that is 18 units. Now, this 18 unit is somewhere done by Bala and Venkat. So Bala and Venkat have to do 18 units. Bala and Venkat together, they're doing 5 plus 4, that is 9 units. So Bala and Venkat together, they're doing 9 units per day. They have to do 18 units. So time taken by them is going to be 2 days. This 2 days is not yet my answer. This 2 days is the time for which Bala and Venkat are working together. Now, when would the work be completed? Work would be completed until this last person, Venkat, is working. Venkat is working for 3 days, given in the question already. Bala and Venkat are working for 2 days, given in the question. Now, first, these two people, they were working for 2 days initially. Total time for which the work lasted, or time in which the work would be completed, becomes 2 plus 2 plus 3, that is 7 days. Total time becomes 7 days. Okay, next question. X takes 4 days to complete one third of the job. Y takes 3 days. So I'm going to write it simultaneously. X takes 4 days to complete one third of the job. Y takes 3 days to complete one sixth of the job. Z takes 5 days to do half the job. If all of them work together for 3 days and X and Z quit, how long would it take for Y to complete the remaining work? Okay, easy question. X is doing in 4 days is doing one third. Total time he would have taken 12 days. Similarly, Y would have taken 18 and Z would have taken 10 days to complete the job. Okay, again, we will begin with that only. Work that they have done is equals to LCM of 12, 18 and 10. LCM comes out to be 180 units. That is, these people, they're completing 180 units. Next thing, I'm going to find out their efficiencies, how much work they have done in one day. So X has done 180 by 12, that is 180 by 12 becomes 15 units per day. Y has done 180 by 18, that is 10 units per day. And Z has done 180 by 10, that is 18 units per day. Okay. See, if all of them work together for 3 days, working together for 3 days, how much work was done? 15 plus 10 plus 18 into 3 comes out to be 129 units. This much work they have done out in 3 days. Okay. Now, remaining work, let's find out. Remaining work, we are going just with respect to question, because after 3 days X and Z will quit. So remaining work becomes 180 minus 129, that is 51 units. Now since X and Z are quitting, only person that remains to do the work is Y. Y is taking 10 days to do the task, or Y is taking 18 days to do the task, and his efficiency is 10 units per day. His efficiency is 10 units per day. So remaining work is 51 units. He is taking 10 units per day. Days that Y is going to do the work, it becomes 51 by 10, that is 5.1 day. Time that is going to take becomes 5.1 day. My answer is option C. Next, how many positive integers not more than 43,000 can be found with the digits 0, 1, 2, 3, 4 if repetitions are allowed? Okay, different questions that repetitions are allowed. Now, what we're going to do, we're going to divide the numbers in a format that Because it is given not more than 4300, so I can form single digits. I can form single digit numbers also. I can form double digit also. I'm going to form triple digit numbers also. But when I'll go on to four digit numbers, I'm going to divide the range for four digit numbers as numbers less than 4000 and numbers between 4000 and 4300. Because if I talk about digits numbers less than 4000, this place will have options. But if I'm considering between 4000 and 4300, I'll have to keep one place as fixed, and the second place, that is this hundreds place, also will have some limitations. So we're going to divide the cases. Okay. We're going to go for each case. Single digits, how many I can form? Let's first go for this. Single digits, I can form 1, 2, 3, and 4. I will only be able to form four single digits because 0 is not a positive integer. 1, 2, 3, 4 are positive integers. Single digit will be 4 only, that is 4 ways. Two digit, if we talk about how many two digits are possible. Okay, again, 0, 1 is not a two digit number. 0, 1 is not a two digit number. What a two digit number is? 1, 0. So the number of double digits that can be formed now. Single digits I know it is 4, double digits that can be formed. Okay, for a matter of fact, 1, 0 is a double digit, 0, 1 is not a double digit. Okay, so here 0 cannot come up, but it can come up at the subsequent spaces. So here I can have 0 at the other spaces, becomes 4 space 5 and 5. Okay, so all the other places can have 0, but not this place. So number of options or number of ways becomes 4 into 5, that is 20. Similarly, if we talk about a three digit number, same concept applies here. 4 into 5 into 5, because 0 1 1 is not a three digit. 1 0 0 can be a three digit, becomes 125 ways. All right, so this is 100 ways. Okay, now next, when 4 is not at thousands place, 4 is not at thousands place. So we are going to consider those cases first. Not at thousands places. So the now thousands place 0 cannot come, 4 cannot come. Options available becomes 3. Okay, but next spaces can have both 3 and 4, 4 and 0. So this becomes 3 into 5 into 5 into 5, that is 125 into 3. Number of ways becomes 375. Now next, if I talk about when 4 is at thousands place, 4 is at thousands place. Also, if I'm putting 4 here, 4 at thousands place, this place becomes fixed one way. Now here it has to be numbers that are less than 4300. So numbers that are less than 4300, that means only 0, 1 and 2 can come here. Ways becomes 3, but here it is 5 and 5 ways that are possible. Okay, number of total ways becomes 3 into 5 into 5, that is 75 ways. Also, not more than 4300 is talked about, but 4300 also becomes one way. Total number of ways becomes 4, 20, 375, and plus 1. When we do all of this, it comes out to be 575. My answer is option C.